Final exam review, starting with problem 13. In this part, we're going to be working on some exponent rules. So for our first problem, you want to notice that you don't have any exponent on the outside of the parentheses. This is a multiplication problem because they're side by side. You can actually rearrange this if you like. Since it's all multiplication, you have the associative property of multiplication. So I'm just going to pull the things that look alike. So I have my coefficients, a 3 and a 5. I have x's, and I have y's. And then I'll just work across. For my numbers, we're going to do plain old multiplication. 3 times 5 is 15. For my x's, they're side by side. Like bases multiplied, you keep the base and add for the exponents. Same thing for the y's, like bases side by side, keep the base and add. Don't forget, if you don't see an exponent, it's understood to be a 1. I didn't say y is 1, the exponent is 1. So 5 plus 1 is 6. So 15, x to the 10th, y to the 6th. So my choice will be A. You have to watch closely on the exponents. We have another exponent rule problem here, and this one, it is a product to a power. Your rule is to take that exponent down to each piece. So we're going to have x to the 5th to the 3rd, y to the 3rd, z to the 4th to the 3rd, and then you have a power to a power. The rule there is keep the base and multiply on the exponent. So 5 times 3 is 15. The y is already worked out, y to the 3rd. And the z is also a power to a power on the exponents. So we're going to keep the base and multiply on those exponents. Our choice this time will be D. In this problem, we have a couple of situations going on. We have like basis as a fraction. We also have some negative exponents there. There are two different approaches. I can show you both. One is to subtract exponents top to bottom when you have a fraction form. And I would just write it when you have a mixture of positives and negatives so that you don't mess up your signs. So just subtract top to bottom. And don't lose a sign there. This is your rule, but you're going to subtract a negative. So minus a negative, remember, gives you plus. So you have a negative 6 and a positive 2 gives you x to the negative 4. When you get a negative answer, you have to rewrite that, and it's going to shift it to the denominator. So something with a negative exponent will shift to the denominator. So right now we have x to the 4th in the denominator. You will write the 1 if there's nothing else there. We'll wait and see if anything else goes there. Now we'll do the y's. Subtract top to bottom, 8 minus a negative 4. Minus a negative makes plus. So we actually have 8 plus 4, y to the 12th. And the rule puts it on the numerator. It's only if it's negative that it will shift. So we have y to the 12th, and that is actually simplified form. A different approach that you can use if you want when you already have a fraction form is to shift anything with a negative exponent to the opposite place and make it positive. You're just applying that rule of something to a negative power being 1 over that. You're applying it earlier. So if we choose to go that route, the things that will shift are pieces with a negative exponent. If they have a positive exponent, we don't move them. So we're going to move it around a little bit. The x to the negative 6 is going down. It becomes a positive 6 when it goes down. X to the negative 2 goes up. It becomes a positive 2 when it goes up. Y to the 8th stays because it's already a positive exponent. Y to the negative 4 will go up and become a positive exponent. Now we'll work with what we have. for the x's, we're going to subtract top to bottom because they are in a fraction form. Will give us x to the negative 4. This is going to rewrite as 1 over x to the positive 4. So it is going to end up in the denominator. We don't have to write the 1 if something else is going to land there. The y's are side by side. Your rule is keep the base and add. So they are going to stay right where they are. So that should be the same answer we had earlier. This time our answer choice will be C. For problem 15, we're going to simplify. They're trying to make you think this is a really hard problem because with that parentheses, you would work inside, simplify all that first. But this one, because the 0 is outside the whole parentheses, it's going to apply to the whole thing. What we're using is our definition of something to the 0 power, which is equal to 1. You just have to watch what is the 0 really with. Since the 0 is right by the parentheses, it's to the whole thing. Now the negative is on the outside of it. So this piece is a 1. You still have the negative sign. So our answer on this one is D. 15b is also using the definition of something to the 0 power is equal to 1. Just notice, what is the 0 really with? The 0 is only with the y. So this piece of it is 1. You still have everything else that was there. So negative 4x squared times 1 is negative 4x squared. So the y to the 0 piece was 1, but it was multiplied by everything else. So our answer choice this time will be A. For problem 16, we have a number that is in scientific notation, and we are asked to convert it to standard form, or it could say decimal form. So it wants you to take it out of this notation. All you're going to do is apply the multiplication. When you multiply by a power of 10, if you have a negative exponent, you're going to move the decimal to the left. If you have a positive exponent, you will move it to the right. So this time we have a negative exponent. Our decimal is going to move 4 places to the left. So here is 1 place. We're going to have to add 1, 2, 3 zeros to have enough spaces. So we will have 0.000, 1, 2, 3. We were after the 1, 1, 2, 3, 4. If you wrote a 0 on the left of the decimal, that is okay. I'm not picky about that, but some of the science classes are. Our answer on this one will be C. For a 16b, we're converting to scientific notation, and the first job is to choose the place to put the decimal. You have to have 1 non-zero digit on the left of the decimal. For this problem, the decimal is actually going to have to go after the 2. So you're going to have 2 point, and then you actually won't have to put that. But that is in your decision-making process. It's times 10, and your exponent on the 10 is the number of spaces you need to move to get back to the original decimal. And if you have to go left, it will be negative, which we do. If you had to go right from here to get back to the original, then it would be positive. You can also think if you have a very small number, it will be a negative exponent. A large number like 2,800, then it would be a positive exponent. Right, so we're going to count. Don't count where you start, count how you have to move. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 times 10 to the negative 8. And you don't have to have that decimal because it's at the end of the 2. Our answer on this one will be C.